Okay, welcome to day one of Precalculus, and I'm going to go ahead and fill in these notes with you so that in case you missed the class or just wanted to come back and review anything you can. First thing to keep in mind is that there are 3 sections stapled together in these notes. We are only going to do 2 sections on day one. So just save it for the next class period and we'll fill in the second or the third part of the notes. Okay, find the X-intercepts and write them as ordered pairs. Well, looking at the graph, we've got -4, 0. We've got -1, 0, and we've got 4, 0. How about the Y-intercept? And again, we're looking on the Y-axis. Where does it cross? It crosses at 0, -3. So note that all our X-intercepts have Y coordinates that are equal to 0. Our Y-intercepts have X coordinates that are equal to 0. And that's true regardless of what any function that we're doing. So if I were trying to find the X-intercept from an equation, I would take the equation and let Y equal to 0 and then solve for X. Every real X I get is an X-intercept. If I want to find a Y-intercept, I let X equal 0. So in the whole equation, anywhere there's an X, I'm going to substitute 0 and then solve for Y to find my Y-intercepts. So let's take an example here. Hopefully you all remember or recognize that this equation is a parabola and it's been shifted down by -4. There's no other transformations. But let's pretend like we don't know that. So it says find the intercepts. Okay, so to find the X-intercept, that means, come up here, we let Y equal to 0. So I'm going to put Y in for 0 in the problem. So Y equals x squared minus 4. If I am trying to solve for x, I need to add 4 to both sides, so I have 4 equals x squared. Solving for x, I take the square root of each side. And when I take the square root of 4 is +2 or -2. So I have 2 x-intercepts. One is at -2, 0. The other is at +2, 0. So I'll go ahead and draw those in on my graph. Okay, there we go. Now let's solve for our Y-intercepts. When we find our Y-intercepts, we substitute x0 for x in the equation. So I'm going to take my equation, Y equals 0 squared. So again, I'm putting 0 in for x, minus 4. 0 squared is just 0. 0 minus 4 is a -4. So my Y-intercept, the x value was 0, -4. So let's go ahead and put that on our graph now, 0, -4. And I can go ahead at this point and graph it in or sketch it in. And we'd go up 1 over 1 because there's no stretches there. And that's what our graph would look like. If we weren't sure how to graph this, we could create a table of values for x and do it that way. Okay, new concept now for you is symmetry. So a graph is said to be symmetric with respect to the x-axis if for every point that exists x, y on the graph, the point x, -y, so the opposite sign of what we started with is also on the graph. It's symmetric to the y-axis if for every point x, y on the graph, the point -x, y is also on the graph. And we'll do some examples to see these. So respect to the x-axis, that means it's reflected across the x-axis. In simple terms, symmetric to the y-axis means it would be reflected across the y-axis. So this looks like it's symmetric across the y-axis. We also have symmetric with respect to the origin. And we haven't talked about this in Algebra 2. So this says for every point x, y on the graph, the point -x, -y is also on the graph. So let's go ahead and take a look at these to see what that means. Okay, so we've got a graph here. This is my original graph. This is point, we're just calling it x1, y1, meaning the first x and the first y, the second x, the second y, the third x, the third y. If this were symmetric in regards to the x-axis, it means that for the x values stay the same, but the y values have opposite signs. So it would be down here. So you replace the y by -y If you get an equivalent equation, that means it's symmetric with respect to the x-axis. When we replace x with negative x, and the equation is equivalent to our original one, that means it's symmetric with respect to the y-axis. So here's an example. If we had this point x1, y1, if it's symmetrical about the y-axis, we'll have this point. For this point, we would have a corresponding point. The x values have opposite signs, the y values are the same. And finally, if we want to see if it's symmetrical about the origin, we would replace y with negative y and replace x with negative x. If the resulting equation is equivalent to what we started with, it means it is symmetric with regards to, it is a reflection about the x-axis and around the y-axis. So again, if you get a resultant equivalent equation, it tells you that it was symmetric about the origin. In other words, it's been reflected across the x and the y-axis. So let's take a look at this equation. And we're going to find the intercepts, and we're going to test for the different types of symmetry. So we're going to do quite a few steps here. I will try and write as neatly as I can so you can see this. So first thing, let's check for x-intercepts. When we're checking for x-intercepts, we set the equation equal to y. So I'm going to replace the y with a 0. So 0 equals x squared minus 9 divided by x squared plus 2. Okay, I'm trying to solve for x. So I need to get this x squared plus 2 out of the denominator. And to get something out of the denominator, you multiply both sides by that amount. So I'll multiply by x plus 2, x plus 2. That's hard to read. I apologize there. So x plus 2 times 0, and then this side times x plus 2. The x squareds plus, x squareds cancel. 0 times anything is 0. So now I have 0 equals x squared minus 9. Okay, that looks better, doesn't it? We're going to solve for x, so we add 9 to both sides. Plus 9, plus 9. We're going to solve by taking the square root of both sides. So we get x is equal to plus or minus 3. This gives me two x-intercepts. One of them is at negative 3, 0. The other is at positive 3, 0. Okay. Let's check for y-intercepts now. When we check for the y-intercept, that means anywhere there is an x, I'm going to substitute 0. So y equals 0 squared minus 9 over 0 squared plus 2. Okay, so if we're simplifying and solving for y, 0 squared minus 9 is a negative 9. 0 squared plus 2 is 2. And I'm going to go ahead and just leave this as an improper fraction. This gives me a y-intercept at 0, negative 9 halves. So that's my y-intercept. These are my x-intercepts. Okay, let's see if we can start testing for symmetry. We'll continue this on another video if I run out of time. Okay, so let's check for symmetry around, or symmetry for the x-axis. When we do this, that means we're going to replace y with a negative y. So I'm going to take my equation, and wherever there is a y, I'm going to replace that with a negative y. So negative y equals x squared minus 9 over x squared plus 2. And I want to get this back now into the original equation with y by itself, and then see if that's equivalent to what we started with. So to get this back to y equals, I just need to somehow take care of this negative sign. And the way I take care of that is multiply by negative 1. So negative 1 times negative y. I have to do the other side of the equation also. So let's do that. That gives me y equals, the negative only gets multiplied on the top because that's really negative 1 over positive 1. So negative x squared plus 9 over x squared plus 2. And let's continue this on the next video.